In this video, we're going to be looking at the moving trihodrum of a curve. And we have three axes here. We have the three planes here. We have the normal plane, we have the rectifying plane, and the oscillating plane. And it is worthy of note to note that this plane moves in an anti-clockwise direction. That means the plane moves to this direction. It moves in an anti-clockwise direction. So in this kind of a plane now, we have what is called a trihodrum. This trihodrum simplifies or stands for the number of planes that we have here. We have three planes, so that is why we have the tri here, so of a curve. So now let us look at these formulas from here, taking into consideration this plane, the normal plane. We are going to have the formula for this particular plane to be beta, which is also known as the normal plane, is going to be equal to this, the cross product of the rectifying plane and oscillating plane, that is this cross n, right? Tau cross n, because it is in the anti-clockwise direction, so we're going to be multiplying this and these two vectors here. So the next one now, opposite of this now, right? The opposite of this is going to be equal to beta bar minus n cross tau. So this is what we are going to have. So for this now, for the rectifying plane, we are going to have our tau. Our tau is going to be equal to this vector cross beta, of which now tau could also be written as minus beta cross n. Yes, so for the last one, which is the oscillating plane, we are going to have our n, this vector, to be beta cross tau, beta cross tau, and which could also be written as minus tau cross beta. So take note of these formulas. They are very important. They are very important formulas. So that is the movement in our trihodrum in this plane, that is in the normal plane, the rectifying plane, and the oscillating plane. This is how they interact with each other. They interact with each other in this sense. So moving on, we are going to be looking at some very other important formulas, and we have to know that these tripartite vectors here, this beta and this, are unit vectors. They are unit vectors, and they have they also stand for some other formulas, for instance now, which are very important. We are going to be making use of them here. The unit vectors, we call them the unit vector, the unit tangent vector, which is this tau of t now, is giving us x prime of t divided by x bar of t. So this is the unit tangent vector, and this was proved in our previous video, but then let's just look at it briefly. Let's look at the proof of this briefly. So we are going to prove this very briefly here the unit tangent vector, this is equal to dx over ds. So but then this is the same thing as dx over dt in chain rule, multiplying dt over ds, which is the same thing as dx over dt or divided by ds over dt. So we could see from here that tau is going to be equal to x prime with respect to t divided by x bar with respect to t, because ds dt is equal to x bar of t. This is from our first video. This is the length of an arc. So this formula is for length of an arc. So it substitutes for dx over dt, which is the modulus of x prime of t. So we have our tangent unit vector to be equal to this. So secondly, let us look at our unit normal vector. The unit normal vector is given to be, we're not going to prove this one. Unit normal vector is given to be tau dot divided by modulus of tau. This is a formula for a unit normal vector. And then lastly, we'll look at our binomial vector. Our binomial vector beta is given as tau cross n, and this we can see it from here. So it's just as it is from there. So these are the component vectors, and these formulas are very, very important. Now we are going to be solving an example briefly to represent to use these formulas, to employ these formulas. All right, we have an example here. Given the curve x of t equal to t, 1 over 2 t squared, 1 over 3 t cubed, at the point t equal to 1, we have to find the tangent vector, we have to find the normal vector and the binomial vector respectively. So to solve this, number one, we're told that tau was equal to x prime of t divided by the modulus of t. So this means if we differentiate this function here, x prime of t, will have it to be 1, t, 3t, so what we are going to do here, we are going to differentiate this function x prime of t, which we are going to have it to be 1 t and then t squared. So taking the modulus of this now, we are going to have 1 squared plus t squared plus t raised to the power 4. But remember what we have is at t equal to 1, which means the modulus here is going to be equal to 1 plus 1 plus 1 plus 1, which is going to be square root of 3. And also here it also implies that x prime of 1 will be 1, 1, 1. So if we were to substitute that into our formula, tau is going to be equal to 1, 1, 1 or divide by square root of 3, which this is going to be 1 over comma 3 comma 1 over comma 3 comma 1 over comma 3. So that is our first solution to our number 1. So number 2, now we have to find our normal vector, and which our normal is tau dot over tau dot absolute value. So but to solve this now, we have to first of all know what our tau dot is. Our tau dot is equal to the tau over ds. It's not the tau over the t. If we have note, this is very important. If we have tau prime, then tau prime is the tau over the t, but tau dot is the tau over ds. So what we have here is tau dot, so is the tau over ds, but the tau over ds is still the same thing as the tau over the t multiplying the t over ds, and this is the same thing as the tau over the t divided by ds over the t, right? And this is equal to the tau over the t. Now will give us tau prime, and this will divide by absolute value of this, because remember ds over dt is equal to, and this is our arc length, and this is the formula for the arc length. So from question 1 we have tau to be equal to this over this, which is literally going to be 1 comma t squared divided by square root of 1 plus t squared plus t raised to the power 4. So we are going to be differentiating this tau now, which tau prime is going to be equal to, keep the denominator constant, differentiate the numerator minus, keep the numerator constant, differentiate the denominator, all divided by the denominator all squared, which is the quotient rule of differentiation. So keeping the denominator, we are going to have 1 plus t squared plus t raised to the power 4 all raised to the power 1 over 2. Differentiate the numerator, we are going to have 0 comma 1 comma 2t minus, and keeping the numerator constant, we are going to have 1 comma t squared into 1 over 2 into 2t plus 4t raised to the power 3 into 1 plus t squared plus t raised to the power 4 raised to the power minus 1 over 2. And this is going to be all divided by 1 plus t squared plus t raised to the power 4. So it is supposed to be squared, but then if you square it, this is square root, then multiplying square is going to be left with this. So tau prime now becomes 1 plus t squared plus t raised to the power 4 all raised to the power 1 over 2 multiplying 0 comma 1 comma 2t minus, now when we look at this side, we have it as 1 comma t squared multiplying 2t plus 4t. This is no raised to the power of 3, sorry. there's no power of 3 here. The 3 is inside. The 3 is inside, there is no outside. Yeah, so this is all divided by 2 into 1 plus t squared plus t raised to the power of 4 raised to the power of 1 over 2. So this is what we have, and then this all is divided by 1, and everything is still divided by 1 plus t squared plus t raised to the power of 4. So what we are going to do next here is that we are going to multiply all of this here. We're going to multiply all of this here by the denominator here, and then take this denominator here to multiply this denominator. So it's more of like taking LCM and then dividing it. So what we will have there, if we do that, we're going to have 2 into 1 plus t squared plus t raised to the power of 4, and if this add with this, you are going to have just 1, so you only have 1 there, and this is 0, 1, 2t, and this is going to be minus 1, t, t squared multiplying 2t plus 4t, all divided by 2 into 1 plus t squared plus t raised to the power of 4. Now if this comes down, you are going to have 1 plus 1 over 2, which is going to give us 3 over 2. So the power here is 3 over 2. So let's open the brackets. We have 2 into, keeping these 2 constant, let's just keep it constant. This multiplying this, you are going to have 0, and then this 0 multiply this, you still have 0, 0 multiply this, you have 0, so everything will be 0. Then this will become a 1 multiplying 1, we have 1 plus 1 multiplying t squared, we have t squared, plus 1 multiplying t raised to the power of 4, we have t raised to the power of 4, comma 2 multiplying 1, we have 2t, plus 2t multiplying t squared, we have 2t raised to the power of 3, plus 2t multiplying this, we have 2t raised to the power of 5. Then at the left hand side, we have minus 2t multiplying 1 multiplying 2t, we have 2t, plus 1 multiplying 4t, we have 4t, comma, then t multiplying 2t, we have 2t raised to the power of 2, plus t raised to multiplying 4t, we have 4t squared, comma, and then we have t squared multiplying 2t, we have 2t raised to the power of 3, plus t squared multiplying 40, we have 4t raised to the power of 3. So opening this bracket, we're going to have 0, we're going to have 2 plus 2t squared plus 2t raised to the power of 4, comma 4t plus 2t raised to the power of 3, 4t raised to the power of 3 plus 4t raised to the power of 5, and this is going to be minus 2t plus 4t raised to the power of 3, comma 2t raised to the power of 2 plus 4t raised to the power of 2, comma 2t raised to the power of 3 plus 4t raised to the power of 5. let's confirm this. This is 40 raised to the power 4 here. 40 raised to the power 4, because we are going to have t multiplying t raised to the power 3. So this is all divided by 2 into 1 plus t squared plus t raised to the power 4 all raised to the power 3 over 2. So tau prime will now be equal to, subtracting this from this now, 0 minus this, we are going to have minus 2t minus 4t raised to the power 3, comma, subtracting this from this, the middle term, we are going to have 2 minus 2t raised to the power 4, comma, subtracting this from here, we are going to have 4t plus 2t raised to the power 3, all divided by 2 into 1 plus t squared plus t raised to the power 4, all divided by 3 over 2. So you discover that 2 is a common factor in both the numerator and denominator. So if you eliminate 2, you are going to have minus t minus 2t raised to the power 3, 1 minus t raised to the power 4, then we have 2t plus t raised to the power 3, all divided by 1 plus t squared plus t raised to the power 4, all divided by 3 over 2. So this is our tau prime, and remember our formula. We have it to be tau prime, tau prime divided by this, and we had x of this to be equal to this here. So what we are going to have here is going to be tau dot is going to be equal to is given as a tau prime divided by this of t, and of which we have tau dot to be minus t minus 2t raised to the power 3, comma 1 minus t raised to the power 4, comma 2t plus t raised to the power 3, all divided by 1 plus t raised to the power 2 plus t raised to the power 4, all raised to the power 3 over 2, and this is dividing modulus of 1 plus t squared plus t raised to the power 4. So the final value for tau dot is going to be equal to minus t minus 2t raised to the power 3, 1 minus t raised to the power 4, 2t plus t raised to the power 3, all divided by 1 plus t squared plus t raised to the power 4 squared. Because by the time you bring this up by law of divisibility, you are going to be having your tau to be equal to this. So our tau dot now becomes the square root of minus 1 minus 2t raised to the power 3 all squared plus 1 minus t raised to the power 4 all squared plus 2t plus t raised to the power 3 all squared. This is power 3. Then this is divided by 1 plus t squared plus t raised to the power of 4 all squared. Then you have plus the last term here. You're going to have it to be 4t raised to the power of 6. Then the next one plus, expanding this here, you have 1 minus 2t raised to the power of 4 plus t raised to the power of 8. Then this is plus the last one, we have 4t raised to the power of 2, 4t raised to the power of 2 plus 4t raised to the power of 4 plus t raised to the power of 6. So all of this is raised to the power of 1 over 2, and this is all dividing 1 plus t squared plus t raised to the power of 4 all squared. We're gradually getting to a conclusion here. So let's simplify this bracket here, this numerator. If you simplify it, we are going to have 5t squared plus 6t raised to the power of 4 plus 5t raised to the power of 6 plus t raised to the power of 8 plus 1 all raised to the power of 1 over 2, and all divided by 1 plus t squared plus t raised to the power of 4 raised to the power of 2. So this is our modulus of t dot. So n now, remember our formula for n now is given as what? This. So we found this and we found this. So to finalize now, this is going to give us minus t minus 2t raised to the power of 3, comma 1 minus t raised to the power of 4, comma 2t plus t raised to the power of 3 divided by 1 plus t squared plus t raised to the power of 4 all squared. Then this is now multiplying this divided by this now. So we have 1 plus t squared. We have 1 plus t squared plus t raised to the power of 4 squared divided by the numerator here, 5t squared plus 6t raised to the power of 4 plus 5t raised to the power of 6 plus t raised to the power of 8 plus, this is all raised to the power of 1 over 2 plus 1 here, rather, plus 1 all raised to the power of 1 over 2. So this, we divide this, and then n of 1 now, substitute the value of 1 now, you're going to have minus 3 comma 0 comma 3 all divided by square root of 18. So this finally we're going to have it to be, we're going to have the final answer to be minus 1 comma 0 comma 1 all divided by root 2. If we further simplify this, this is what we have. So quickly let's run through to our number 3. Our number 3 way to find the vector component beta, which is tau cross product of tau and the normal vector. So we've already found our normal vector and our tau. We found our tau to be 1 over root 3, 1 over root 3, 1 over root 3. I will find our normal vector to be 1 over root 2 minus 1 over root 2, comma 0, comma 1 over root 2. So this implies that this is going to be I, j, k of 1 over root 3, 1 over root 3, 1 over root 3, minus 1 over root 2, 0, 1 over root 2. So I will be this, multiplying this, 1 over root 6, minus j will be this multiplying this minus this multiplying this, that is going to be 0, because this will be root 6, which will be 0. Then we are going to have plus k, this multiplying this 0, this multiplying this, that will be plus 1 over root 6. So the final answer now, beta, is going to be in the component of 1 over root 6 comma 0 comma 1 over root 6. So this is our tau, this is our normal vector, and this is our binomial unit vector. So this is a solution to the given question. Thank you for watching this video. Please subscribe to this YouTube channel and don't forget to hit the notification bell to get notified each time we upload a video. Thank you.